exponential equations and E. Spent quite a lot of time on what E really is, and that we have an approximate value for it. Here's a definition sort of that we used the other day. So this is one way that we can define E. In calculus, this expression would be written with a limit notation, and that would be that E is the limit of n going to infinity of 1 plus 1 over n to the nth. So the limit means that, what value does it approach as you get closer and closer to infinity. E to the x is often called the exponential function because it's the base that occurs frequently in applications, whether the applications are in nature in terms of growth of bacteria or decay functions or a lot of other different places where you run into E as well. A lot of statistics is based on it, and so it's an important concept. It's very useful. So let's look at the graph for E to the x. So myself a little more space. So what do we know about exponential functions? Well, we know that they have an asymptote. So in this case, it's e to the x plus 0. So this is an asymptote, with this being the x-axis. We know that anything to the power of 0 is 1, so an exponential function often goes through 1. And we just said that e is worth about 2.7-ish. So at 1, it would be worth about 3, just shy of that. And that means that at a negative 1, it would be, like 1 over 3-ish. So we'll just use those two values. And then make it approach an asymptote. And on this side, it goes up rather quickly. So that's e to the x. So let's use transformations on this one. Say to the main, the range, and the horizontal asymptote. Okay. So we're going to start with e to the x. Well, the negative would be a flip across your x-axis, right? So if we used to be at 0, 1, I'm going to count by 2 there. So now I'll be at 0, negative 1. And then the x minus 2 well, the 2 is tied to the x, so that is a shift. And I think that will be a shift, right? Because we are what we're really interested in is when is x minus 2 equal to 0. So this would be where you would base it. Well, it's supposed to be 0, or it's supposed to be 0 at 0, but because of the minus 2, we actually shifted the 2 to the right. So this dot needs to be, we said that was 2, right? So that's 1. This dot needs to be there. Okay, what else then? Well, at 1, we are almost at 3, right? So 1, 2, 3. So now if you go over 1, you should be almost at a negative 3. So that's a negative 3. That's close to a negative 3. And that means that over here we get that 1/3. So overall, it looks a little like this. State the domain, the range, and the horizontal asymptote. So the domain is all real numbers. You can plug in any x that you want. The range, well, we go from 0 to a negative infinity, right? And usually we write that the other way around. So this graph goes from a negative infinity to 0, but we don't quite get there, so it's an open bracket. And then the horizontal asymptote, in this case, still equals y equals 0. So on this one, e to the negative x plus 2 So the plus 2 is a shift up, right? So that is a horizontal asymptote is now at 2. And then the negative x makes it go across the y-axis, right? Because the negative is tied to the x, so the negative x is across the y-axis. So we'll do the e negative x first. So that is a flip across the y-axis. And then a negative x plus 2 is a shift up of 2. And that's it. So in this case, 1, 2. So we have a new asymptote. It's supposed to be at 0, 1, but we're a little higher now. So we're going to be right there. And at 1 then we should be at 3. So 1, 2, 3. And then here you should have the 1/3, but those are going to flop. So the 1/3 goes here, and the 3 goes on this side. So this is what it looks like. I'm having trouble with the asymptotes. So the domain, the range. So the domain, all real numbers. The range from 2 up to infinity, and the horizontal asymptote I did up there. I can repeat it, y equals 2. Alright, solving exponential equations. It says make sure the bases are equal and you can solve for the exponents. That just means this. Okay, if I could only write 81 as a 3 to some power, with whatever power I have here, I know x plus 1 has to equal this, otherwise this doesn't work. So that's one of the things you often look for. Well, 3 to the 4th is 81. So if those two are equal, then these have to be equal. And then we get x equals 3 right there. Okay, what do we have over here? Well, we have a giant mess, don't we? On this side we're pretty good, but on this side we have a whole bunch of stuff going on. So we need to clean up the right side. So it's e to the power of 2x. Exponents multiply, right? Exponent on exponent. And then I'm going to write this one as e to the negative 3rd, because when you multiply you can add exponents. So I actually get, that's awful, I get e to the negative x squared is equal to e to the power of 2x minus 3. Well, that means that a negative x squared has to equal 2x minus 3, or x squared plus 2x minus 3, and that factors, I think, into x plus 3 times x minus 1 equals 0, so a negative 3 or x equals 1, and that should work. So that one has 2 answers. Okay. Properties of exponential function. So we've already seen some of this in terms of what they look like and what they do. And then here, that little blurb over here, this is what I just used to solve this stuff. So if you have like bases, so if the bases are both a's, and if that's a 5, then the only way that this will work is if you have a 5 on this side as well. Okay, thank you.